Hello everyone, so today we are going to solve another interesting problem number 2965, find missing and repeated values. And it's a interesting problem to solve because it could be applied in real life applications. We see this problem time to time. So what we have been given one zero index 2D integer matrix, grid of size n by n, meaning the number of rows and columns are equal with values in the range from 1 to n square. Each integer appears exactly once, that's a constraint, except one which appears twice and another which is missing. So our task is to find the repeated and missing number A and B. So we want to return a zero index array, answer of size 2, which where 0 th index will contain the repeating and first index will contain the missing number. Okay. So I can do this problem via two approaches. So I'm going to show you both the approaches together. So the first approach that I can use is I can do this via hash map. So what we will do is we will build one hash map for our integer grid matrix that we have been given. So this is the initial matrix that we have been given. So in parallel to it, we'll create one count integer matrix, so that will have the number of elements n square plus 1, because we are moving from 0 up till n square. So for 0 index we put just 7, 8 and 9. So for first 0 it could be anything. We'll initialize this whole list with zeros, and as we will see the items in the original grid, we'll update these values with the count, and in the end, we'll return the missing and repeated number from this element, from this 1D array that we have created. So we'll put 0 with, for 0 index, we'll just initialize one value of 1, and we'll see have we encountered 1 in the original list integer matrix. If yes, then we'll update it with the new value and we'll update the count. Similarly, we'll see second time 7, so we'll update this 7 with 1, and since we have seen initially first n 9, we'll update n count also by 1. Next we have encountered 8, so we'll increment the count of 8 by 1. Similarly 9 we have seen twice, so we'll increment it count by twice. 3 we'll be seeing for the first time. Similarly 4, so we'll update 4 with first. 6 we'll update with 1. 5 we have not seen, and 2 we are seeing for the first time. So now we'll just iterate this array that we have created, and we'll return the index whose count is 0, and the index whose count is 2. That will give us the return, and that will give us the repeating and the missing number. So our repeating number would be this one and the missing number is this. So this would be the one approach for solving this problem of finding repeated and missing values in the 2D array. So this approach has a time complexity of O of n square, and we are also using one 1D array of size n square elements, so that space complexity is also O of n square. So let me first write this solution, and then we can look into how we can make this solution. Can we reduce the better? Can we reduce the time complexity? So we'll ponder upon this question once I write this approach first and see how it performs. So this is the first approach. This is approach 1 that I'm going to write it out. So we have the size of grid n, and we will be creating one 1D array of size n square plus 1 like we discussed. So that how we can declare in Python. And now for every list in grid, we will be traversing in the numbers in list and we'll be updating the count values for the number that we have seen in the list by one. And in the end, we want to return the index 2, which is the repeating number, and one, index of 0, which is the missing number into our uh, array. Uh, so now let's run our solution and see how it performs. Okay, so now let's run it for other example test cases. So it has been accepted and let's submit this first approach of ours. And that has been accepted and it's pretty fast, but in space and time complexity is of O of n square. Now the real question is, can we make this approach better? Can we reduce the time complexity? So for that, I'm going to answer that can we reduce our space complexity from O of n square? So the answer is yes. We can reduce from O of n square to O of 1 by doing in place 2D cyclic sort. So what we'll do is, so let's say we'll again pick our original integer array list, and what we'll do is we'll start placing the numbers at its correct place in the way that this list was originally sorted. So what we'll do is we'll place 9 at its correct position, that this should come at the end. So that so in the next iteration we have 6, 1, 7, then 8, 9, 2, and 3, 4, 9. Similarly, we'll place 1 at its correct location. So the actual location of 1 is over at 6. So that will come 1, 6, 7, and we'll be placing 7 at its correct position. So we can place it over here. So we can bring 3 directly over here, and then 8, 9, 2, and 7. So that is for the first row that we are in. Now in the second row that we are iterating, we'll place the 8 at its correct position. This is 4, 8 at its correct position with 4. So we'll have 1, 6, 3, then 4, 9, and 2, and 7, 8, 9. Then in the next iteration, will 9 will be, we don't need to replace 9 with 9 because they are both at the correct position. Because the original 9 is the, and this is one is the repeating 9, so we'll just skip this loop when we going to write the code, and now we'll place 2 should go to its correct position, so it will swap with 6, and the original list will become 1, 2, 3, 4, 9, 6, and 7, 8, 9. So now just by traversing in this original list, in this in place sorted list, by swapping that we have created, we can check in one place what numbers are not in. So we'll check the numbers by keeping one variable with the numbers values. So 1, 2, 3, 4, 5, 6, and 7, 8, 9, and we can clearly see that number 5 is missing from our original list, and this number has been repeated. So this would be repeating twice. So This operation we are going to write via coding that we want to do, and I'm going to show you how we can write this approach algorithmic wise so that our space complexity is reduced from O of n square to O of 1. So I'm going to need that for writing the code that we are. So we need the number of rows and number of columns into our original from our original grid that we have, that we can get by finding the length of the total 2D list and the list of each individual list in the grid. And now we'll use two variables, so row and column, to traverse the original list. So for traversing the list inside the list, I will be using C variable, which is basically we are traversing the columns, and for traversing the rows, I'm using the R variable. So we'll say that while C is less than N, we want to check like what is the correct position where this row should be and where this column should be, which we'll get by using the quotient and the modulus operator in the from the grid value that we have. So grid minus 1, this will give me the quotient, and similarly we'll take out the remainder also. So now we'll get the remainder using the modulus operator from the n. Now we'll check if this element in our grid is at its correct position or not. So if it is not, then we'll swap it with the where it should be. Otherwise, we'll just we'll skip the loop. So that is what I'm writing over here. So now we'll just skip the grid R comma C. Similarly, grid of position of R comma position of C is equals to grid of position R where it should be. Otherwise, we'll just skip that element if we have seen it before, like for the 9 case that we have. And if we have traversed this whole list, then we want to go to the next list that we are in. So this way we can see that if I print the original grid now, then we will be getting this original list in the sorted order that we wanted. So let's check this once. Now let's run it for seeing that we have ordered in the right manner that we want. So yeah, we have 1, 2, 3, 4, 9, 6, 7, and 9. Now by traversing just this grid sorted, cyclic sorted manner, we can grab our repeating and original number. So for that we need one repeat and one missing variable to pick those numbers. So we'll go in the original number of rows and the original number of columns to compare these grid values with the number that we have. So number is a 1D matrix. So number will form just by the number of rows that we have plus in which column we are iterating, and 1 plus 1 for the, since it's a one index array, so it's the numbers are starting from 1 to n square. So for that the extra one, and now just we just want to compare that if this grid value in which I am currently, if it is not equals to number that in which I am, then I will say that this is my repeating number, and otherwise the missing number is the number which I have never seen in the original sorted cyclic sorted list. And we want to return these two numbers from repeating and missing. And now let's run our code and see how it performs. Okay, so we have the orders, we have the number in the correct order, and let's now submit our code and see how it performs both ways. So it has also been accepted for all the test cases and it is running pretty fast. So the time complexity for this algorithm is O of n square, and the space complexity we have reduced from original from O of n square to O of 1 using the cyclic sort that I just showed you. So that's how we solve this problem. So thank you for liking and subscribing the channel. If you want me to create more such awesome content and algorithms, please like and subscribe to the channel so that I can come and bring more algorithmic values for more algorithms for these problems that I'm solving along with you in your interview journey. Thank you, and let me know if you have any particular problem that you want me to solve, and I'll see you tomorrow.